So now let's talk about the rectangular inequality. And this is one that I think really confuses people. I know the first time I ever studied this concept with copulas, I was very confused by it and had a really hard time rationalizing why the formula looked the way it did. And I think a lot of people kind of end up in that situation where they just kind of give up on trying to have any kind of intuitive understanding of the rectangular inequality and what it's trying to say. And they just try to memorize this formula, which I think is a little bit dangerous for exam purposes, because I think it's far more important to understand conceptually how this formula came to be. And I stumbled across a YouTube video a while back that had a very crude presentation given by a professor in India, I believe, and he sketched out a really useful visual on a piece of paper, and I kind of borrowed his approach and transformed it into something that looks a little bit nicer and a little bit more formal that I'm putting here on this slide. And I think if you can understand how to calculate just the basic area of a rectangle, just very basic geometric concepts, if you can understand that, I think that will help you understand the rectangular inequality and make it unnecessary to simply memorize this formula, because you'll just understand what it's saying. And once you understand that, this formula will just fall out naturally. So if you can understand how to calculate the area of the blue box, then you can understand the rectangular inequality. So let's forget about probabilities and joint distribution functions and all that, and let's just, go back to a two-dimensional space. Okay, x and y can be anything, okay, just values that increase from left to right on the x-axis and increase vertically on the y-axis. You can see that x1 is greater than x2, y2 is greater than y1, so we can basically have four coordinates and we can build a rectangle of any shape. And, clearly, if you had the actual values for these coordinates, you could calculate the area of this rectangle very easily by just subtracting, x2 minus x1, y2 minus y1, multiply them together, and you have the area. But suppose you didn't have that. Another way you could get the area of the rectangle is by first calculating the area of this big rectangle, basically a rectangle that has, one side equal to x2 and then another side equal to y2. Okay, you could take that area and then you could begin subtracting the area of the rectangles around it. So if you start with the area of this big box and then subtract the area of this rectangle and then subtract the area of this, thinner rectangle underneath, you're almost there, but you've subtracted this little box twice, and so you have to add it back. Okay, so that would give you the exact area of the blue rectangle. So if you can understand that and just keep that visual in your mind, you can understand the rectangular inequality, because what it's really trying to say in the two variable case is that the joint distribution function should be two increasing. In other words, it should be increasing in both probabilities. And so if both probabilities increase, the joint distribution function should increase. And so if we imagine that our blue square is now, down here in two-dimensional space, and now we visualize a joint cumulative density function, okay, just imagine you bake a really funny shaped cake that, is three-dimensional, obviously, and you take your knife and you just start slicing out pieces of cake in the shape of that rectangle. What you'll want to see is that the side of the slice that you cut out over here is taller than the slice on this side over here, which is, again, just saying that as you increase those marginal CDFs, okay, the joint distribution function itself has to also be increasing. And that's exactly what the rectangular inequality is trying to say. You can also see how you could calculate essentially the volume above that rectangle. Again, if you just imagine a piece of a big cake and you just start cutting it out, if you've got, the cumulative density at this far corner over here, and then you just start subtracting the other corners, you can get the volume just above that blue rectangle. So again, hopefully if you can visualize that, you really don't even have to memorize this formula, because it's just a natural calculation if you understand what it's trying to say. And by the way, it's also another good way to calculate these probabilities, because any one of these probabilities is a meaningful amount, and if an exam problem gave you maybe all but one of them, you could easily solve for the other.